some confusion on struggling with on the assignment so far. And it seems like there's been a lot of confusion on frames. So tool frame, user frame, and Brenna thought a refresher on the tool frame might be good. So let me ask you, what is the point of using a tool frame?
So you can have a program oriented at the end of the tool, not just based on the position of arrow.
Right. I guess I should turn this on. I guess just as an example, I'll
That's very JM. Yeah, I just made a giant B and a giant B. Exactly. That's way easier than that. Justin going off being a perfectionist.
The easiest example I could come up with was the welding, right? Because if you're welding something, you're dragging. And so if I wanted to, can you see this one okay?
Yeah.
I wanted to weld there, right? And say I wanted to drag a weld this way, and then I want to come on top and drag another weld that way. Or how about this? I just had a really good idea. Really good idea, guys.
Uh-oh, Zach.
All right. I'm going to weld this book to this laminate. So if I'm not a very good welder, but I do know that I need to be on a 45 this way, and then also a 45 this way, right? I'm dragging it because I want it to be a 45 going down into that joint, right? So how do I do that setting up without a tool frame? Just write a program here. And I'm in, you know how to look to see where what frame you're in right now? I just showed you.
Coordinates. And then you can use shift coordinate if you're
Right,
under
so
tool.
shift coordinates. And I'm in tool frame 1, jog 1, and user 1. So unless somebody has written over tool frame 1, if I rotate it on these three, the yaw, pitch, and roll, at I'll just bump it up to 100% so you can see. Because I'm in joint. I'm going to go to the world. Can you tell where it's making those, where the center point of the rotation is?
Yeah, it's like right where you screw on the tool.
Yeah, by default, it's right here. And you can kind of see that. Whoa, wrong. No matter which way I take it, it keeps that point right in the same place. So if I wanted to put the end of this so-called welder at a 45 this way and a 45 this way, I would have to jog it over there and then do all sorts of weird stuff to get it to look just right. Or I could go into joint mode and see if I do that, it's rolling in the wrong spot. So I got to move it even more. close. And then I want to roll it that way. So how do I do that? We have a very long tool. So do you remember how to do the teaching part?
To have a point at the end of the tool. And then you orient the tool in different 45-degree directions, keeping the tip on the point.
Right, basically we have a couple of options. We can either take measurements straight down from here, which we need like a, what do you call those, a square? To make sure we're measuring straight down this way and then straight down, straight that way. We could tell it exactly where that is, or we could teach it. So let's run through teaching it again. Okay, so what do we want to call this tool frame?
Welding.
Weld. Pick a number between 1 and, or it's like 2 and 5. Is that what you're using? Aren't you using tool frame 5 out there? Oh, okay. All right, so how do we do it? How do we do it?
So you want, to go to the menu. And then you want 6 for setup. And it's 3 for frames. Oh. Yeah. Arrow down to 6.
There we go. So user frame right now, number 5 is called BC marker, which I'm assuming means black marker. Probably a good choice. Let's just leave it at that. Detail. And it is not taught. How can I tell that? Coordinates are all 0 and it still says uninit.
Uninit uninitialized.
Uninit. The active tool frame right now is number 1. And I think that just means in whatever program it has pulled out. Circle. Somebody's got a program named Circle.
It's probably Joseph's.
Yeah.
Jason.
All right, so let's go back to frames. What am I doing? 6. Okay. So we teach approach point 1. What should I do there?
So pick a left corner point somewhere. Bigger.
It can be anywhere, right? We're just picking one single point that we can put the tip of that thing exactly where on the same point every time. So I'll just use like
Plus
this.
sign, yeah.
I'll just use that little crosshairs right there. You remember what I told you about the 3 different locations? The best results you're going to get is if you're at a 45 and as spread out as you can be. Because if you do 3 locations like this, it's not going to be as accurate as if you spread them out. You know what I mean? You don't want them to all be like this either. So I'm going to jog it. Just in some random 45. And then what do I do? Record.
Right?
Yep. Shift, record. Point recorded. Approach point 2. I'm going to lift it straight up. Give it a little slap and tickle.
So you're doing that in world mode.
Yeah. So there's point number 2. Shift record. I'll hit shift record for the 3rd one. And then when I do that, all of these numbers change. X, Y, and Z, all pitch and roll. And all of those units want to use, it says new position calculator. So I'm going to go plus Z and lift this bad boy up. You know, I'm going to put it down. Right on that same point. And then if I want to roll this straight that direction, what do I do?
So you need to make sure you're in the tool frame, right?
Right. Good point. First step, shift coordinates, and I'm in tool frame 5. So now I'm still in world.
Just do coordinates, right?
Our user,
No, I can keep it in world. So now if I want to roll this straight in that direction, what axis does that point need to roll around? That's the x-axis, right? So if the tip of that marker is my finger and I want to roll it around that x-axis, that's yaw for joint number 4. So if I hit plus x direction, I think that's plus, just depending on where your z is. Let's see, I'll put it to 50%, and then I'll do plus x. You see how it's keeping the tip of that marker right there? So instead of, when I want to go, let me straighten this thing out. And I'm still in worldview. I can still go z this way, x this way, y this way. But if I want to roll that thing around a certain axis, it makes it a lot easier to be using that tool frame, doesn't it? So now I want to do this weld. And just how it sits, if I want it to be in a 45-degree into this joint, what axis do I need to roll it around?
So you can roll it Y.
I need to roll it around the y. So if I go in the plus y direction, I'm just jogging it right now. That'd be this one. Cool, huh? And then I go minus z, bring it in close to that joint.
Make it right in cursive. Open that like that.
Let go, extra credit. Initials and cursive.
Right, I'll hold it at the 45.
Perfect, perfect.
Okay, so now I'm in a 45 this way, but if I'm welding, let's say I want to drag a weld along this way, I also need to have it in a 45 in that direction. Make sense? So I need to roll it towards me. How do I do that? Which axis is that?
Negative X.
Right, so that's the x-axis, and I want to roll it this way. I think it's plus x.
That's
Oh,
way.
you were right. So this is minus x. So in 2 moves, I've gone 45 that way, 45 this way. Instead of having to adjust every single joint, to get it exactly where you want it. And now, in my program, I put a point there, and then I just jog it in the negative x direction,
Big X direction.
plus
right?
y direction. And it stays right along that line. Cool, huh? And then let's say I wanted to jog this way, and then I want to do another bead of weld back on top of it going the other direction. All I have to do is roll it around which axis?
X-axis.
Should be the Z, right?
Oh.
Right? If I roll it straight around this axis to the other side,
Isn't that fancy?
cool, right? And then
Around the world.
I go this way.
Uh-oh.
Didn't like that. I guess I can't drag it that way. I don't have the reach. Yeah, you see what you're saying. Oh shit. Oh, I just destroyed my marker.
Come on, man.
Why didn't you tell me I was still at 50%?
Sorry, guys.
Your fault.
Yep, all involved. Must be fired from class.
Alright, so weld this way. Roll around. Weld that way. You get the point now, right? Oh, didn't like that. Oh, didn't like that. Straighten it back up. That is your tool frame. All because we taught it exactly where this is. Make sense? All right, so what about user frames? You're taking notes on there, right? Yeah. User frame?
So user frame is in relationship to the outside of the machine. So you can orient it to one side or the other, not just the way the machine's oriented.
Yeah. And it can be on a plane. So right now, the default plane is flat like a piece of table because that's how this thing is mounted to the table, right? So then you have an X, a Y, and a Z relative to that plane. But either you watch the video that's on Blackboard under this assignment with the German guy, Peter Detmer. In his example, in your assignment, all you're going to do is write something there, move it over here, write something there. He taught it in his video like this, and then he had a document holder where he went like this. And the second time he drew that line or whatever it was, I don't remember. It can go on an angle. So you could actually teach X, Y, and Z here, or X and Y here. How does it know where the Z's at?
It is if it's working on a plane.
Yeah, and if you got a positive X direction one way and a positive X the other way, Z is going to be straight up plus direction. If you get those backwards, right, it's fine. You can still use it. It just if you teach it this way, write your program, and then flip them when you teach it the second point, it's going to think the Z-axis positive is straight down, right? Because you're basically telling it that you flip the piece of paper. So that's the gist of user frame. And you're teaching user frame the same way by teaching 3 points, but you're using a center point and 2 directions. 10-4. Anything else you want to review?
That's it. What's going on last one?
So you were gone last week when we talked about, or was it the week before, the assignment, right? So there's you were here? No, I think it was just you and Justin were here when we talked
It was
about.
Friday out.
Friday, I wasn't here.
So there's some robots here, and they're yellow. The one with the suction cup on it, that's got a bunch of I/O. There's a terminal strip out there, and that's how you have things like the conveyor and stuff. I'm probably going to make changes to this. Don't worry about trying to do this right now, but it just seems like you guys have a lot on your plate project-wise already. But what I'm going to do is get all the stuff installed. So all you have to do is pull the wire, and I'm not sure